Still on physics for beginners, we'll be considering the fundamental units and quantities. Length is the distance between 2 points, and the unit is meter. Example of length is the height of a building, which is 100 meters. Amount of matter in an object. Unit is kilogram. Example is mass of a block, which is 0.5 grams. Time, which is the duration of an event. Unit is seconds. An example is time to complete a race, which is 10 seconds. Temperature is the measurement of thermal energy, and the unit is Kelvin. Example is room temperature, which is 293 Kelvin. Electrical currents, flow of electricity charge, and the unit is ampere. Example is current of a wire, 2 amps. Luminous intensity, measure of light brightness. The unit is candela. Example is brightness of a lamp, which is 100 candela. Amount of substance, number of particles or moles, and the unit is mole. Example is mole of gas in a container, 2 moles. Now let's go to derived units and derived quantities. Derived. All the ones we have discussed so far are fundamental quantities. That is length, mass, time, temperature, electric current, luminous intensity, amount of substance. Now let's go to derived quantity. Example of derived quantity is area, the product of two lengths. And the unit is meter square. Meter square is the unit. Another one is volume, which is the product of 3 lengths. And the unit is cubic meter. Example is volume of a container, 5 meter per cube. Speed. So among the derived quantities, we have speed. Speed, which means distance traveled per unit time. And the unit is meter per second. Example is speed of a car, which can be 60 km per hour. Another one is acceleration. Acceleration is change in speed per unit time. And the unit is meter per second squared. Example is acceleration of an object, which is 9.8 meter per second square. Another one is force. Another derived quantity is force, which is a push or a pull on an object. And the unit is Newton. Example is force applied to an object, 10 Newton. Another fundamental derived unit is energy, which is the ability to do work. And the unit is joules. Example is energy consumed by a bulb, 100 joules. Another derived unit is power, which is the rate of energy transfer. And the unit is watts. Example is power of a motor, which is 100 watts. Another derived unit is pressure, which is force per unit area. And the unit is Pascal. Another derived unit is density, which is mass per unit volume. And the unit is kilogram per cube meter. Other derived units include hertz, that is the unit of frequency, Newton per meter, unit of tongues, watts seconds or watts per seconds, unit of energy, coulombs, unit of electricity charge, farad, unit of capacitance, Henry, unit of inductance, and ohms, unit of electric resistance. there are some key concepts that we must understand. One is dimensional analysis. That is the converting units using dimensional equation. Then unit conversion, converting between different units to the same quantity. Unit conversion, converting between different units to the same units. SI units, International System of Units, which is used globally in physics. So in other words, we have looked at fundamental quantities, like we mentioned length, mass, time, temperature, electric current, luminous intensity, amount of substance, and we look at the right quantities and units. We talk about area, volume, speed, acceleration, force, energy, power, pressure, density, and Hertz, Newton per meter, watts per seconds, coulombs, Faraday, and Henry. All these are fundamental units. So we shall continue from this in our next class.